A, prove that 1 plus sine 2 theta over sine theta minus 1 plus cosine 2 theta over cosine theta is equals to cosecant theta. So first, seeing that I have double angles in trigo, we can make use of some formulas to change the look of it. So these are the formulas that are given to you in your formula sheet. Okay, and for proving questions, always start from the more complicated looking expression because it's easier to simplify than to make something easy look more complex. So for this question, I'm going to start from the left-hand side where we have 1 plus sine 2 theta over sine theta minus 1 plus cosine 2 theta over cosine theta. I'm going to focus on the cosine 2 theta first. From your formula sheet, we see that there are three ways to rewrite cosine 2 theta. So which one should I choose? I'm going to choose the one that can help me get rid of this addition sign here, so that later on I may be able to cancel terms to simplify my fraction. Remember that we cannot cancel terms when we have addition or subtraction. We can only cancel terms with multiplication or division. So the one that I will choose will be 2 cosine square theta minus 1, where the negative 1 here can actually cancel away with the positive 1. So we have 1 plus sine 2 theta over sine theta minus 1 plus 2 cosine square theta minus 1 over cosine theta. Okay, and we have 1 plus sine 2 theta over sine theta minus this 1 will cancel away and we are left with 2 cosine square theta over cosine theta. And now we have cosine on top and below. We can cancel 1 cosine theta, which means my numerator will be left with 2 cosine theta. Okay, so we have 1 plus sine 2 theta over sine theta minus 2 cosine theta. Okay, so bearing in mind that I only have one term on the right hand side, I will be combining these two terms into one. And to do so, I must first make sure that they have the same denominator, which means my second term here, I will need to multiply it by sine theta over sine theta. This will give us 1 plus sine 2 theta over sine theta minus 2 cosine theta sine theta over sine theta. And with that, we can combine your numerator together. We have 1 plus sine 2 theta minus 2 cosine theta sine theta over sine theta. 2 cosine theta sine theta is actually the same as 2 sine theta cos theta, which we can rewrite as sine 2 theta. So here, I will have 1 plus sine 2 theta minus sine 2 theta over sine theta. And now this positive sine 2 theta can cancel away with the negative. I am left with 1 over sine theta, okay, which is exactly cosecant theta, which is what we have on the right hand side. Okay, and we have proven question 9a. For part B, hence solve 1 plus sine 2 theta over sine theta minus 1 plus cosine 2 theta over cosine theta equals to 2 sine theta for theta between pi and 3 over 2 pi. So from part A, we have already proven that this expression here is cosecant theta. So we have cosecant theta equals to 2 sine theta. And cosecant theta can be written as 1 over sine theta equals to 2 sine theta. Okay, 2 sine theta is the same as 2 sine theta over 1, which means we can cross multiply to get 2 sine square theta equals to 1. Okay, and now to make sine theta the subject, I will first divide throughout by 2 to get rid of the coefficient. So we have sine square theta equals to half, and sine theta will be equals to plus minus square root of half. Now, to determine whether I should take the positive or negative value, we need to consider which quadrant theta is in. And we can do so by drawing out our quadrants. Over here, we have 0 radian, pi over 2, pi, and 3 over 2 pi. So, given the range here, where theta must be between pi and 3 over 2 pi, we can conclude that theta must be in your third quadrant. So, theta is in the third quadrant over here. And from your ASTC, okay, we know that in your third quadrant, only tangent is positive, which means sine theta is negative, and we have to take sine theta equals to negative square root of 1 over 2. And this is the same as negative 1 over square root 2. To solve for theta, we must first find the basic angle. Given that theta is in the third quadrant, your basic angle is alpha over here, and this is the size of your theta. So first, to find your basic angle, we have sine alpha is positive 1 over square root 2, and alpha here is sine inverse 1 over square root 2. Okay, this is actually one of your special angle, which will give me pi over 4. So now to find theta, we can see that it is actually pi plus your basic angle here. So we have pi plus pi over 4, which will give me 5 pi over 4. So this will be your answer.